All right, y'all. This is the last little bit of the 5 point. What are we on? This is 5.6. Sorry, I'm losing track because I'm planning notes for other things. But of 5.5. Sorry. So this is the last little bit for the 5.5 notes. There we go. And this should help you to complete the last little bit of your homework. It's about complex numbers. And if you recall, complex numbers are those that have I in it. They can be written in this form, like A plus BI. And all the way back in what was it, like chapter 2 or something like that? It was like a long time ago. Towards the beginning of the year, we were graphing complex numbers just on a plane using like rectangular coordinates type of deal. So we talked about how we could do that. But just, for the sake of argument, if we're able to take rectangular coordinates and graph those on the polar grid, then technically, if I can do complex numbers in that capacity, then I could also plot them on the polar grid. And we're going to kind of see how that would look. Okay. So, anyways, when we talk about complex coordinates and things like that, the way that it relates to your rectangular coordinates is this relationship here. So you can see the complex number 3 plus 2i. We can represent that as the rectangular coordinate 3, 2. So again, that's like giving you an x and a y coordinate kind of to be plotting on that grid. Now, if I was actually going to try to do polar, then we actually have to think about this a little bit different and see how we can apply that in a polar capacity. So just remember that x equals r cosine theta from our last video, and y equals r sine theta, again, from our last video. And so if I have an x and a y coordinate, then I can use those same kind of relationships in order to write my coordinates as complex. Now, complex is going to be in this format right over here, right? So that we have r cosine theta plus, so that's like the a value, plus the r sine theta, the b value. Again, I'm getting that a and that b from this a plus bi situation. Okay, so that's kind of the structure there. A is acting like the x, b is acting like the y, r cosine theta plus I times r sine theta. Now, I will go ahead and tell you before we go through an example here, the way that this question is really wanting us to work the problem on example 6 is not really how I would instinctually do it, because they said that they want us to express the complex number using the polar coordinates r theta. But what they gave us are the rectangular coordinates. So if they did not include this last little sentence here, I would just jump to taking these rectangular coordinates and writing them as the complex number -2 minus 2i. That's all I would need, because you can just take those values as the a and the b and plug them in a plus bi. However, this last little sentence here is telling us that they want us to do this in a certain way. They want us to get there by first figuring out the polar coordinates, r theta, and then getting our complex numbers. And I think, honestly, that's just to try to show us how everything ties together. But that's what we're going to do. All right. First things first, we're going to have to figure out what the rectangular coordinates are in order to go through it the way that they want. So remember the way that we can do that. This acts as like the x and the y, and I can do the Pythagorean theorem to get r. If you don't know what I'm talking about, go back and watch the last video, okay? But the Pythagorean theorem, we would be doing -2 squared plus -2 squared equals r squared, and just go through solving this. -2 squared is 4 plus 4, we get 8, equals r squared. Square root of 8 is r, and I could simplify that to be 2 square root of 2. Okay, so again, that's just there to give me a little bit of a, just to give me that r value. And I do like to simplify these down because in the long run, it can make your answers nicer. Okay, so next thing I've got to do is figure out what the theta would be. So we've got our theta we're going to get by doing tangent. So we're going to do that. Tangent of theta, and that's going to equal y over x. Remember, it's sine over cosine. So that relationship, again, if you don't know what I'm talking about, go and watch the last video. I'm putting y over x. Now they happen to be the same thing here. Okay, so tangent theta equals -2 over -2. Tangent theta equals 1. So I've got to figure out, where does tangent equal 1? There's two places where tangent is 1 on your unit circle. So I'm going to kind of sketch this really quick to make sure that I'm talking about the correct location. The point -2. -2 is going to be over in here, right? And so in this quadrant, this angle for theta, right, that's going to be 5 pi over 4. All right. So next thing, we've got our r and our theta. Now they want us to use those to get the polar coordinates. No. Yes, to get the complex ones. Sorry, I lost track. Hold on one second. Okay, announcement over. So I paused the video so that you didn't have to hear the whole thing. Anyways, we have, in this situation, we have our r, we have our theta. Okay, let's go and figure out what the complex coordinates are going to be, or the complex number would be. The complex number has the rectangular coordinates, blah, 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 right? Okay, now how are we going to get there? I'm going to take this r cosine theta, and we're going to take this idea for r sine theta, and we're going to plug those values in. I know r and I know theta, so let's plug those values in. All right, so I've done all that. Let's bring this in where I'm looking at r cosine theta plus I times r sine theta. All right, we're just going to plug in those values. R was 2 square root of 2. We have cosine of 5 pi over 4 plus I times the r sine theta. Okay, now we're going to start calculating this stuff. So I'm going to leave the 2 square root of 2 here. Cosine of 5 pi over 4. Now if I look at cosine over here, all students take calculus, right? Cosine is going to be negative down here. So cosine of 5 pi over 4, we are looking at the x coordinate at the point here. That's going to be -√2 over 2. So again, it's from the unit circle where I'm getting that value from, but that should be -√2 over 2. We have I times 2 root 2 sine of 5 pi over 4. You look at that same location. You say, okay, what's going on with my y coordinate here? Oh, that's negative, and it's going to be, again, -√2 over 2. So, again, I'm getting that from unit circle. Okay. So I'm going to clean this up some. We're going to see what cancels. This 2 here can cancel with that 2 because they're not under square roots. This one with this one, again, they're not under square roots, so that's fine. The square root of 2 times the square root of 2 makes the square root of 4, which is 2. So this is really -2 because we have that negative there. Plus, then we have this I times square root of 2 times square root of 2, square root of 4. Square root of 4 is 2. Again, this was negative, so -2. And we got -2. This is -2i, which is exactly what I said it would be if I was going from the rectangular straight to the complex. But they wanted us to go about it this kind of roundabout way. Now, if they give you the polar coordinates, that is kind of what you have to do, is you would have to do plugging this stuff in right here. And then go to get your, but if they just give you rectangular, guys, you can do a shortcut, especially if it's a multiple choice question. Okay, example 7. They said a complex number is represented by a point in the complex plane. Using polar coordinates, the complex number can be represented as, or expressed as, blah, blah, blah. Express the complex number using a rectangular coordinate. So we're working with this guy. This is our complex number, okay? And this is they used the r cosine theta, r sine theta situation to write this complex number. Okay, they didn't actually simplify it all the way down like they could have. They just kind of had it shown that they plugged it in like this. But what I can tell from here is I can tell what my r is and I can tell what my theta is. So right here, this tells me r, this tells me theta. Okay, it's the same thing over on this other one. So I said express the complex number in its rectangular, using its rectangular coordinates. Well, remember that x is equal to r cosine theta, right? And y is equal to r sine theta. Why don't we use that? Plug these numbers in. So this would be 4 cosine 7 pi over 6. 4 times the cosine of 7 pi over 6, that is times negative square root 3 over 2. Again, you get that from the unit circle. All right. I go ahead and cross cancel with this 2. 2 goes into 4 twice. And so that makes negative 2 square root of 3 for the r, or for the x value. All right, for the y, we got 4 sine 7 pi over 6. All right, now 7 pi over 6, sine there is going to be at negative 1/2. Okay, negative 1/2 times 4 is a negative 2. So the coordinates, this is my y, the coordinates would be the negative 2 square root of 3 for the x coordinate and negative 2 for the y. There we go. All right, guys, that is it for this video. Like I said, example 6, technically, in theory, we could have gone straight from the rectangular coordinates to the complex number just because we know that relationship. But what they wanted us to practice is being able to see how all of it corresponds together so that you can do harder problems or things that are slightly different than this, okay? So these are skills that you will need to use in all kinds of different problems. And then this one down here is just a little bit more straightforward because I didn't ask it in a weird way. All right, that is it, guys. That is it for 5.5. I'll see you in the next video. Bye.